Good afternoon, everybody. I'm back. Going to try to do another video tonight and see how it goes. Want to talk about seeing clearly within an environment. Uh, this is something that I have a real passion about. I think it's really important to have strong visibility into your environment and see what's really going. So we're going to talk about visibility for NetOps and security operations. Prevention versus visibility. Whenever you're talking about prevention versus visibility, I think they're related for the most part. If I really want to prevent attacks or prevent any type of security issue, I really have to have visibility to my environment. And the only way I can really get that visibility is I always have to be looking for the real truth. I have to be looking for what's really happening in my environment and not something that can be manipulated. Prevention requires you to be able to see the problem. In order for you to stop it, you've got to be able to see it. If you can't see it, you can't prevent it. So visibility is key to security and really to performance too. You have to be able to see what's going on. So I'm going to spend a little more time talking about it. So you've got some really tough questions that you have to answer. You have to think about things for your users. From an IT ops perspective, what is the user experience? It's really important to actually try to figure out how to measure that user experience. From a security ops perspective, are logon credentials compromised? That's something that everybody wants to know. From an IT ops, can users and servers authenticate? Can they authenticate? Do they get that single sign-on? Is there a problem with single sign-on? It affects the user's experience. Is an attacker enumerating my system? Brute force attacks. I still contend that a lot of brute force attacks are missed because people aren't paying attention to the right things. Which servers are responding slowly? IT ops. I want to know what's slow, what's fast. Um, what is the speed that is normally happening, so when the development team releases something, I can tell that there's a difference. Maybe I need to figure out for my load balancers how often they need to health check. There's just a lot of things for when servers are responding. From a security ops, is that encrypted traffic malicious, right? So is it dangerous? Is it potentially bad? From the IT ops, which queries need to be optimized? Does unusual activity indicate recon? Is an attacker accessing your company data? What's the app's performance? Is there unusual access to sensitive files? These are all things that you really need to think about having visibility into. And how would you get that visibility? And that's a question that I often ask many companies. How do you get that visibility into your organization? And I think visibility is key. And it's something I've kind of contended with for the past 15 years of my IT career. I've really tried to tell people that they need to have visibility into their environment, i.e. monitoring logs, monitoring the network traffic, monitoring the storage, monitoring the servers themselves. You have to have that visibility to really understand what's going on. And many companies talk about high availability. There is no such thing as high availability without having visibility into what it's doing. We see many times high availability cause more problems than it actually alleviates, and most of the time that's because people aren't paying attention to it. They don't have the visibility into what's actually going on. Same thing goes from a security perspective. We can talk all day long, but if we can't see what's going on, we have no way of determining whether our environment is under attack or whether somebody's already taken data out of our environment. You've got to have that visibility. So when you think about it, you have a lot of endpoint protections, a lot of things within the security arena. You have firewall, IPS, IDS, advanced threat protection, endpoint protection. You have this other side of the house that's all the things people need to do to effectively make the business work, right? You have cloud, you have IoT, you have BYOD, you have storage, file servers, all your users, your database, your transactions, your applications. All of those little things that are happening in your environment is a lot to keep an eye on that happens multiple places. So it's really important to realize you can't find what you can't see. Network is often a black box with limited visibility as to what is really happening. Wired data does not lie. So once you get wired data, once a bad guy has to initiate some sort of traffic, it really doesn't lie. He can't get on that wire, pull it back off, change it, manipulate it, put it back in unless he's doing man in the middle. But depending on where your tap is, you may be before or after that tap. So it's really difficult for it to lie. and it is the nearest thing to real truth that's out there. So I really find this very, very important to follow through with. So as we've kind of talked about, why is wire data visibility so important? We can do a lot of things visibility wise with different things, i.e., Wireshark or log or endpoint protection. Problem of it is it doesn't cover everything. I think it covers an awful lot, but like if I have BYOD devices, definitely not going to get anything from them log wise, and I'm definitely not going to get anything from endpoint protection. So the only way you're going to be able to see that data is by looking at it on the wire. In many cases, network is often invisible. Lots of things happen that we do not know about. A lot of people aren't aware of the amount of data that you can get off of the wire. Logs are based on what the developer wants to get you. So if you take a look at logs, what oftentimes happens is that developers write their logs for events that they know about. If they don't know about a type of event that might happen, a failure, a success that might happen in certain situations, they don't log it. So you're kind of dependent on the developers to write the right information and drop it to the logs. And you're also kind of dependent on the fact that the logs will be there, right? That you've actually set them up to log, you've set them up to drop, and the fact that the logs are going to be there all the time, because if somebody really understands or knows or has figured anything out about your environment, they can really create enough events to overrun those logs. We see it happen a lot of times with DNS, and not necessarily by somebody doing malicious activity, but because events happen in your environment. When you have a client, and you'll see it in some of my videos, that does 800,000 queries in a 5-minute period, that overruns the logs. And so, yes, you can stream the logs, but then it makes it very difficult for whatever tools you're using to analyze that data and pull something out of it. Logs can be manipulated. So it is possible for an attacker to manipulate the logs. They can erase them, they can do many things, and there's things you can do to protect against that. But again, these are all possibilities. Wire data is difficult to manipulate. It arrives at the server or at the client, whichever side you're working from. And going through to the client, you have to have had something either attack it before or after, depending on where it's going. You can do man-in-the-middle things. You can pull stuff off the wire and slip it back through. But ultimately, if your tap is right at the server side, that data will come into the server and you can see it. Or if you've got a span going, you should be able to see those kind of things happening. And it's really hard for an attacker to detect that those things are actually happening. Signature-based solutions may be slow by days in some cases, because if I'm waiting on a signature, maybe you have a 0-day that's happening. Sometimes bad stuff is going out without a signature, or bad stuff is getting in without any type of signature because it just hasn't been found yet, right? So these are all important things that you have to think about, and some of the reasons why you might want to look at some sort of wire-based tool to analyze what's happening on your wire. Wire data gives you great insight into DNS, insight into the TCP handshake, file names, URI information, errors, more things than I can list. It's amazing the amount of data that you can pull off the wire if you really think about it. And so having that ability to, say, look at the login page and know how many times that login page is hit, how many times a username is hit, how many times that same username or multiple usernames comes from different IPs. That all has to pass across the wire at some point in time. So it's really important that people understand that they can take advantage of this in several different ways. So wire data is extremely important. Let me give you some examples. So WPAD. A lot of people I talk to talk about the fact that WPAD should be off. WPAD is not the greatest thing to have in your environment, and oftentimes I want it to go away. They want it to go away. I know a company that worked for a long time to try to get rid of it, and come to find out when they got some wire-based tools on there to monitor it, it was not really gone. You can see here how it kind of died off towards the end of April, and how they were starting to make headway into limiting WPAD. Pretty cool stuff. So here's a case where wire data pays off and looks pretty good. You have an active sync server or active sync logons. How many people are actually paying attention to how many times you have failed logons or successful logons? Maybe you want to pay attention to both. OWA logins. How many external to internal OWA logins? Those kind of things are actually important to be able to monitor, and they're difficult to do in some cases, even with the IIS logs. They're difficult to parse. So this is something that you can pay attention with wire data if you know what you're looking for. DNS response errors. So I've got 7,000 requests, and suddenly I have a ton of responses. Why do I have the great big spike in DNS requests, right? And DNS responses. Why is it that 1,000 of them are erroring out? This could be a significant problem in my environment and would be something that I would want to know about. Could it be an attacker? Could it be somebody doing something malicious? It's possible. So these are the kind of data things that you can get off your wire. A lot of people, when I bring up the DNS stuff, they say, well, just gather your DNS logs and stick it in the SIM. Problem of it is what happens when you have DNS requests going out to something that isn't even one of your DNS servers. Not all environments have DNS locked down, so it has to come from a DNS server to the outbound world. And so if you can do an NS lookup in your environment and hit Google, odds are your environment's wide open, and I can, as a malicious person, could actually put something on your network and be doing DNS queries out to Google and not even hitting your infrastructure. So the idea of wire data doesn't care what it's hitting. It's just looking for DNS requests and responses. So if it sees it on the wire, it's going to count it. It's going to mark it. It's going to know things about it. So this becomes really important to take a look at how would I gather that data and how could I take advantage of that data. And wire data and wire capture type data is one of the best ways I can think of to do it. And RevealX from XtraHop does this better than anybody I've ever worked with so far. I think it's pretty powerful. So let's take that information a step further though, because now I have all this network detection equipment are out there, or all this network data, right? I have all this wire data going across that I'm pulling into some device, and in this case, we're going to do NDR, network detection and response. So we're going to see that data being brought in, and that data is going to be analyzed, and then give us a detection and we can take a look at that to determine if we want to respond to it. So in this case, this is a potential domain generating algorithm is detected. So a lot of people aren't even aware of this kind of behavior in an environment. Malicious software will basically be written with an algorithm in it that will run through different DNS names. So the command and control group of whoever's managing that malicious software, they basically have the same algorithm sitting on their servers, and then once a day or twice a day or whatever they decide to do, they take and buy a couple of domains and start up those domains, right? And so the malicious software is constantly checking to see different domains. And this is really hard to find. The algorithm is very difficult to kind of find, and it's one in a million. In this case, we've got several hundred. We have 53 queries, but that 53 queries was in that 7,000. If you remember the slide from before, there were 7,000 requests. 53 of those queries were from that 7,000 requests or responses. And this was able to tell us that that was a potential problem, right? Something to look at. Again, here's a single case of it. You've got a name, looks interesting, looks like something that you might want to deal something with. So I think this is pretty cool that we get this detection telling us that there's a potential domain generating algorithm that's running off of a client. And that's pretty important to us. Do we want to get to things early before it starts doing other things before command and control? Cool thing is we can look at this and we can see all of these requests failed, which means there's no domain out there, or whatever tool we're using to block that, whatever other DNS capabilities that we might have, maybe blocking that and just returning no such domain. And maybe those domains aren't registered yet. Either way, it gives us some ability to go, hey, we might want to look at that client to see whether it has malicious software on it. So I think this is, again, becomes really powerful in this scenario that we get these kind of detections from RevealX. In this case, DNS internal reverse lookup scan. One of the things that if somebody gets a foothold in your environment, it's likely, it depends on how noisy they are and how crazy they might be, but it's likely that they might take and do a reverse scan of your DNS for the IP range that they're on, or maybe other IP ranges that they know, so that they can see what the name of some of the servers are. And really being able to detect this is really kind of a cool feature set that you can look at and say, hey, something did a reverse lookup scan, and only for my internal environment, not doing the external side, those kind of things. It does make it nice when that it's just looking at the RFC 1918 addresses and can tell me that it's something scanning our internal network or our internal DNS. Suspicious user agent. So you can see in this case, this was a mass scan tool that somebody wrote and put on GitHub, and they left the user agent string in there. And so when people use this to scan our environment, we know about it, right? Or somebody internally, maybe that it's a malicious tool, but we can see the different URL agents and possibly suspicious ones that we may want to take a look at. So this again gives us a detection. We don't have to hunt for it, it just detects it and says it's there. It sees it because it saw it going across the wire. Again, really powerful tool for us to see things that we didn't even think about looking for in some cases, because RevealX has an entire group of security people building these type of detections as they hear about them, as they know about it, as they see them in other networks. They're trying to build this stuff out to tell us that it's a potential threat and that we may want to take a look at it. Yeah, it's possible for it to be a false positive, but they give us the tools to quickly drill in and go, yeah, I can move on. So oftentimes these detections are often cleared in anywhere from 1 to 3 minutes. If we see one that's more malicious, then it may take longer for it to clear, right? So really good tool for us to hear and see and understand some of the bad stuff that's happening to us, or potentially bad stuff that's happening. What about ransomware? Can we detect ransomware on the wire? Absolutely. Can you see IOCs on the wire? Absolutely. So things about that ransomware, like the help file, can see when a device reads and writes large volumes. What would happen if you knew that the same device read 1,000 files and wrote back 1,000 files? Would you be concerned about that? Is that normal behavior? Something worthwhile. Detections of specific file types, i.e. The help encrypt file that's left behind. Those kind of things become important for it to look at, right? So here's some potential ransomware activity detected. And so the client read 900 distinct files and wrote data for 1,000 distinct files. That's a concern. We read a bunch, we wrote a bunch. That absolutely is a concern that we would want to know about, right? It could be a client is having a problem. Maybe it's doing something it shouldn't. Maybe a process is stuck. But I would still want to know about this kind of behavior. Here's more ransomware, about the more detail around it and how we can investigate it, and more things to look at as a part of it, right? And so this is all within the detection card of RevealX, which is really cool in my opinion. Suspicious SMB file share access. So this is where we get more detail around that ransomware and how things change. So you get a timeline that shows you these devices and how you have an offender and then the same offender hitting again. So you see over here, the same offender is doing some more ransomware activity again. So the current detection is this one. This is the second one. This is the defender, and you can kind of see the defender hitting the victim and then the victim becoming the offender. So you see the separation there of that take place. So now we kind of know there's something malicious going on. Why would the victim become the offender? Hey, I got bad stuff on it, and I'm now using it to start doing ransomware activity and read files. And so you can see fairly quickly that this is a potential problem, right? Again, having this data is really helpful, and having this visibility, I think, is pretty powerful. TCP Scan Detected. This is part of that prevention step. So you see things being scanned, TCP SYN scans. I want to know more about it, right? And you can see that the defender, same defender became the victim, and so on down the line, and the participants. You can see that timeline of when things started to happen, and you can kind of see it progress from a TCP scan. There was some DNS internal reverse lookup scans. Drupal vulnerability was exploited. So now this TCP scan that I saw, I can look at, and just prior to it starting was a DNS reverse lookup scan. Prior to that was a Drupal vulnerability that was exploited, and a web directory was scanned. So the web directory scan found that it had Drupal. They exploited it with Drupal, or the Drupal vulnerability was exploited. DNS internal reverse lookup scan. Then they did a TCP scan of those servers that they found. Potential PS exec server activity, more, and then potential SIFS brute force attacks. So now they're getting more in depth. So you can kind of see how timeline is built out of this wired data. Again, really powerful tool to give you that kind of detection when needed. So I hope you liked this video. I apologize for the dog barking in the background. That was just part of it. But here's some of the other things I've written about. I've got a blog, my external blogs at mitchrobertson.blog. The value of wired data, too much DNS, why wired data is out there. Extra Hot blog has a few things that I've written. DNS is set it and forget it protocol. It's out there on the Extra Hot blog. Monitoring SMTP with wired data is out there on the Extra Hot blog. If you've got time, take a few minutes, subscribe to my channel. Go look at my blogs and give me a like. Leave me some comments. If you've got information, got questions about any of this, let me know. I'd appreciate it. Thanks, and have a great day.